Systems by Elimination Day number 1. So this is officially our first day that we're going to be solving systems using the elimination method. However, let's not forget that there are some methods we've already learned that we use to solve systems. The first one was by graphing. Graphing is nice and quick if all the circumstances work nicely, which means it's already in slope-intercept form and things like that. Now, if it wasn't that case, we would also try using substitution. So now it's a matter of, okay, what if I can't graph it? What if I can't use substitution if it doesn't work out nicely? What are some other options? Well, the next option that we have is going to be, of course, elimination. Okay, so our content objective is we're going to be able to solve a system of two equations by elimination. So it's a new method. Language objective is students will be able to describe how to eliminate a term to solve for a variable. So that is new. We're not going to be substituting. We're going to try to eliminate a term in order to solve for one of the variables. Now, why is this important? Well, it's important for real-life problems like, this is just an example, how many of each shirt or pants could you purchase if you're given a specified budget? So, with that said, let's jump straight into our first example. The instructions say, solve using the elimination method. The first thing I want you to understand about elimination is our goal is to try to cancel out one of the variables by adding down. Okay, it's going to make more sense when we try an example. So, first things first, you want to make sure everything lines up nicely, which means the x's line up, the y's line up, and so do the constant, and especially the equal sign. So everything's lined up very nicely, so this is going to be a prime example to use for elimination. Here's what you're going to want to do. Again, you're going to try to cancel out the variables by adding downward. So here, 2x and 3x aren't going to cancel each other out. However, a positive y and a negative y will. So watch what happens. I'm going to go ahead and put a line right underneath, and I'm going to add downwards. Positive y and negative y will cancel out, leaving us with just a 0. So now I'm going to continue to add. By, first of all, recognizing that I've eliminated my y's, now all I have to worry about is x's, which allows me to solve for x. So here we have 2x and 3x. If I add those together, I will have a grand total of 5x equals 6 plus 4 is 10. So now it's just a matter of solving for x, which is a lot easier than to try to solve for 2 at the same time. Since this is a multiplication, I'm going to try to do the inverse, which is to divide both sides by 5. You're going to find that the 5's are going to cross cancel, leaving me with just x equals 10 divided by 5, which is 2. So now that I have part of my answer, I'm going to go ahead and start my solution. Solutions are always written as x, comma, y. As of right now, I do know that x is 2, so that's what I'm going to write in for x. So now it's just a matter of figuring out what y is. Just like with substitution, I have a choice between the first equation or the second equation. For me, what I'm going to try to do is always pick the equation with the smaller numbers, and whenever possible, the equation that has the most positive values. That way it's less tricky. So if I was given the choice between these two equations, I would prefer to go with the first equation. Now, is it going to make much a difference? In this case, not really, but it's also important to understand I could have chosen either of these equations and I should have gotten the same answer regardless, as long as I'm doing the arithmetic correct. So I'm going to go ahead and choose the first equation. So here we have 2x plus y equals 6. But let's not forget what we know. We do know that x equals 2. So I'm going to go ahead and plug this into my x, and only x. So here I'm going to go ahead and put 2 parentheses for x. Let's put that there. Plus y equals 6. So what goes in here for my x value? Well, let's see. What is x? X is 2. So I'm only going to put in a 2. So now that I have that, I'm going to distribute. 2 times 2 is 4. 4 plus y is 6. So now all that's left to do is to get rid of this constant. In order to get rid of 4, I'm going to subtract 4 from both sides. That's going to cancel out. which just leaves me with y equals 6 minus 4, which is 2. So now that I have that, I can go ahead and complete my solution. Y is a 2. But a very good practice is to make sure we check the solution to see if it really does work for both equations. I'm going to go ahead and rewrite this. So 2, but parentheses for x plus parentheses for y, and it should equal 6. I'm going to now plug in the information that I know. X according to my work is a 2, so I'm going to put in a 2 here. Y according to my work is also a 2, so I'm going to put a 2 there. So here you definitely have the option of just simplifying it by hand or using a calculator. I think the numbers are easy enough, so I'm going to go ahead and simplify it in my head. 2 times 2 is 4, plus, bring down the 2, does that equal 6? Yes, I would definitely say 4 plus 2 is 6. So it works for the first one. But now I need to check if it works with the second one as well. So I'm going to do the same process. 3 times parentheses for x minus parentheses for y to check and see if it equals 4. So according to my work here, x is a 2, y is also a 2. Now that I simplify it, I'm going to get 3 times 2, which is 6, minus 2. Does that equal 4? Absolutely. 6 minus 2 is 4. So it does check out for both. And remember, it's important that they do check for both. Because I checked my work and it works for both equations, I can confidently say that the solution is indeed 2, 2. So now that I've done an example for you, what I'd like you to do is try the next one by yourself. You're going to be given 3 minutes to try this by yourself. You may begin now. Okay, so let's see how well we did. Because you've already done this, I am going to go just a little bit quicker. So first, I'm going to double check everything is set up nicely. The x's are lined up, the y's are lined up, so are the equal signs. With this given system, you're going to notice the x's cancel out nicely. So I'm going to go ahead and cancel them out, or in other words, eliminate. That's why it's called elimination. Now I'm going to add them straight down. 3y plus 1y gives us a grand total of 4y equals 5 plus 3 is 8. So now that I have that, all I'm going to do is solve for y. Since this is multiplication, we're going to do the inverse, which is to divide both sides by 4. The 4's are going to cross cancel, leaving us with y equals 2. So as of right now, I do have part of my answer. So I'm going to go ahead and start my solution. Solutions are always written as an ordered pair, x comma y. So here, I'm going to go ahead and fill in that y is a 2. So now it's just a matter of figuring out what x is. It really doesn't matter which of these equations you use to solve for x, but whenever possible, try to pick what is easiest for you. For me personally, I think the second equation is going to be easier, so that's what I'm going to use. Negative x plus y equals 3. As a reminder, let's not forget that y equals 2. So I'm going to go ahead and plug in 2 for y. I'm going to get a negative x plus parentheses for the y to plug in equals 3. So what am I plugging in for y? Well, according to my information here, y is 2. So I'm just going to go ahead and distribute, but wait a second. Is there anything really to distribute? Not really, because you are distributing a 1. But just to clean things up, let me write it like this so that you can see it a little bit better. Now, a lot of students don't do this because there's not much of a difference there. But let's go ahead and subtract 2 to get rid of the constant, leaving us with negative x equals 3 minus 2, which is 1. Now, here is where you need to be very careful. There is a negative 1 out here. Since there's a negative 1 out there, you want to divide both sides by negative 1, which is going to leave us with the negatives cancel out, the 1's cancel out, which is just x equals a 1 divided by negative 1, which is negative 1. That is our answer here. Now, hopefully, you've also checked your work. So let me show you how that could have been done as well. For the first equation here, we have x, so parentheses for x, plus 3 parentheses for y. It should equal 5. So for x, according to my work, it is a negative 1. y according to my work is a 2. So here I am going to show you how you can use a calculator because some of you may need it. Yes, most of you can do this in your head, which is great, but some of you may need to use a calculator to just double check with the arithmetic. So I'm going to show you real quick how you can do that. What I want to make sure is this equals 5. So let's go ahead and get a calculator and let's plug in what we have. We have a -1 and we're going to be adding 3 times 2. Does it equal 5? The answer is yes. So it checks out. Okay, so now let's go ahead and check the other equation because remember, it's important that it works for both, not just one. So for the second equation, we have negative parentheses for x plus parentheses for y, and it should equal 3. Using the solution I came up with, x is a -1, y is a 2. So again, if you wanted to use a calculator, you're going to plug this in to make sure that it equals 3. Once again, just in case some of you may need this, I'm going to show you how you can use a calculator. Simply type in exactly what you have on your work to see if it does equal the same thing, which guess what? It does, so I can confidently say that this is my solution. It does work for both of them. Okay, so now moving on to another type. For this one here, same idea. What I'm going to do is first check if everything's set up nicely. The x's are, the y's are, the equal signs, we're good to go. Now I'm going to check to see if any of the variables will cancel out. And the answer is yes. You're going to find that I can go ahead and cancel out the x's. -2x plus 2x is 0. So they automatically eliminate without me having to do anything. Now we have 5y plus 2y. That gives us a grand total of 7y. And now we have -10 plus 10. Be careful, -10 plus 10 is 0. Now sometimes when students deal with the number 0, they kind of panic a bit, but don't. Let's think of it this way. Is there a number you can think of that we can multiply by 7 to make it a 0? The answer is yes. What is that number? Hopefully you said 0. But if you didn't know, you could have just gone through the normal steps and said, hey, this is multiplication, so I'm going to do the inverse, which is to divide both sides by 7, leaving me with y equals 0 divided by 7, which is 0. So now that I have that, I could get my solution started, which I will do right now. As always, it's written as an ordered pair. X's are written first, Y's are written second, and I can go ahead and say Y is 0. Real quick, because some of you may have this question, some of you may be wondering, wait, is this 0 or is it undefined? If you need to, simply divide it out. 0 divided by 7. Is there a number you can multiply by 7 to make it a 0? Absolutely. The answer is 0. Okay? So think of it that way. Sorry, this is a 0, not an 8. Looks pretty bad. Okay, so now that we have y, we're just interested in figuring out what x is. And let's remember, you can choose any of these two equations. Me, personally, I am going to go with the second one. Why, you might ask? Because the numbers are smaller and numbers are positive. I'm going to go ahead and use that equation. We're going to do 2x plus 2y equals 10. Let's not forget, we do have some information. We do know y equals 0. Okay, so I'm going to go ahead and plug this in for my y, and only y. So that's going to leave me with 2x plus 2, parentheses for the y, and it's going to equal 10. What goes in for y? Well, according to my work, y is 0, so I'm going to plug in a 0 here. So now we're given 2x plus 2 times 0 is 0 equals 10. This 0 is not going to make much of a difference, so I'm going to rewrite it without the 0. Now it's just a matter of solving for the x. Since this does mean 2 times x, I'm going to do the inverse, which is to divide both sides by 2. The 2's cross cancel, leaving me with x equals 10 divided by 2, which is 5. I can go ahead and fill in my solution. X is 5, and there I have an answer. As always, let's make sure that we check our work because that's the best way to make sure that we have the answer correct. I'm going to go ahead and copy down the original equations. So negative 2 parentheses for x plus 5 parentheses for y, and it should equal negative 10. So what is x? According to my work, x is a 5. And what is y? According to my work, it is a 0. Here, I think that the work is pretty simple enough, so I'm just going to show you the arithmetic. Negative 2 times 5 is negative 10. 5 times 0 is 0. Is this true? Does negative 10 plus 0 equal negative 10? Yes, it does. Okay, so now moving on to the next one. We have 2 parentheses for x plus 2 parentheses for y, and it should equal 10. According to my work, x is a 5, and according to my work, y is a 0. Whoops, this is a 0. Let's see what we have. 2 times 5 is 10, and 2 times 0 is 0. Oops, 0. Does 10 plus 0 equal 10? Correct. So I am confident that my solution is 5, 0. Okay, so I have a couple typos. First of all, it says solve the following by substitution. It should say elimination instead. My mistake there. I apologize. And also, my numbering went off. This should have been 4, 5, 6, etc. But we're just going to go ahead and leave it as is. Okay, so now what I'd like you to do is go ahead and try 5 by yourself. You're going to be given 4 minutes. Your time begins now. Okay, so now that you've given it a shot, hopefully you were able to get the answer. If not, please make sure you correct your notes now. First, I'm going to check that all the x's line up, the y's line up, the equal sign lines up. We're good to go. So here, I'm going to notice the x's conveniently eliminate themselves. I didn't have to do much. Here we have 10y minus 8y, which is going to be 2y, equals negative 30 plus 26, which is going to be negative 4. We're going to solve for y by dividing both sides by a 2, which leaves us with y equals negative 2. So for my solution, I can go ahead and begin, which is basically x comma y. We know y is a negative 2, so hopefully you got that part. Now it's just a matter of solving for x. Let's not forget, I can choose any of these two equations that I want. Personally, I'm going to go with the second one just because the number seems slightly smaller. I'm going to use 5x minus 8y equals 26. Let's not forget what we know. As of right now, we already know y equals negative 2, so I'm going to plug that in for y and only y. Now I have 5x minus 8 parentheses for y equals 26. So what am I plugging in for y? Well, according to my work, y is negative 2, so let's plug in negative 2. Now we have negative 8 times negative 2, which is positive 16. Bring down the 5x. Bring down the equals 26. Let's get rid of this constant. Instead of adding 16, we're going to do the opposite, which is subtracting 16. So I'm left with 5x equals 10. So now what should I do? Well, since this means 5 times x, I'm going to do the inverse operation, which is to divide, leaving me with x equals 10 divided by 5, which is 2. So now I have my answer. X is 2. So hopefully you've checked your work. I don't want to bore you with that. So we're going to go ahead and move on to number 6. Okay, so for number 6, it's slightly different, okay? For number 6, if you check, everything is nicely lined up. The x's are lined up, the y's are lined up, the equal signs are lined up. But one thing different about number 6 than the rest of the ones that we've been doing is none of these variables cancel out nicely. The x's don't cancel out, neither do the y. But by taking a close look, you might notice y is close to being eliminated. One's negative, and that's not going to work. In order for it to eliminate, one has to be negative, one has to be positive. So what I'm going to do is I'm going to manipulate one of the equations. Which one am I going to manipulate? I'm going to manipulate the second one, and I'll explain in a second why I chose the second one. So all I need to do is make sure one of these y's are positive. Well, if it's negative right now, the only way to make it positive is by multiplying it by a negative 1. So watch what happens. Negative 1 times 2x is now going to turn into a negative 2x. Negative 1 times negative y is now going to turn into a positive y. Negative 1 times 6 is a negative 6. So let's not forget to put our equal sign and a negative 6. So I've transformed this entire equation to now look like this. So notice you're going to change it by multiplying every term by negative 1. Now, I'm going to keep the original equation the same. I'm going to put 8x minus y equals 24. By doing that, you're going to see that I've successfully eliminated the y's. That leaves me now with 6x equals 24 minus 6, which is 18. Now it's just a matter of solving for x. We're going to divide both sides by the 6, leaving us with x equals 3. Beginning our solution, always written as x comma y, I can go ahead and fill in what I know. X is 3. Now, just to solve for y, what I want to do is use one of the equations. It does not matter which one I use. For me personally, I think the second one's nice, only because the numbers are smaller. So let's use that one. Let's use 2x minus y equals 6. I'm going to go ahead and remind myself that I do know that x is 3, so plugging that in for my x. I am now going to have 2 times x, parentheses for x, minus y equals 6. So what is x? X is a 3, so plugging in a 3 there, I'm going to be left with 2 times 3, which is 6, minus y equals 6. Let's go ahead and get rid of this 6 by subtracting 6 from both sides. If negative y equals 0, you're going to have to divide off that negative 1, and you're going to find that y is 0. Why? Because a negative times a 0 is still 0. Anything times 0 will be a 0. Okay, so once more, I'm going to go ahead and show you how to check. This is probably going to be the last time I show you how to check your work. Afterwards, I'm going to assume that you remember how to do it. Here, I'm going to write the first equation. We have 8 parentheses for x minus parentheses for y, and it should equal 24. What is x? According to my work, it's a 3. What is y? According to my work, it is a 0. One more time, for those of you who need to use a calculator, this one's not going to make much of a difference, okay, but I'm just going to show you anyways if you needed to. You could simply plug this into a calculator to make sure it equals 24. Here we go. Given a calculator, I'm just going to type in what I have, which was 8 times 3 minus 0, and you see that it does equal 24, so it does check out. Now, most of you won't need to plug it into a calculator, but again, I'm just trying to show you how easy it could be to plug it into a calculator if need be. Next one, we have 2 parentheses x minus y, parentheses for y, equals 6. What is x? According to our work, x is a 3. According to our work, y is a 0. So here, I'm not going to show you using the calculator because this one's not difficult at all. So I do want to show you how you can do it in your head as well. So 2 times 3 is 6 minus 0. Does that equal 6? Absolutely. So it does check out. So I am going to show you just one more, and then I'm going to let you try number 8 by yourself. For number 7, I am going to show you how to do it, but I won't do the checking just to make sure that we have enough time to get through this lesson. So for number 7, again, you want to check that everything lines up nicely. The x do, the y's do, the equal signs do, the constants, we're good to go. Here, can I eliminate anything? The answer is no. These won't cancel out because 5x plus 4x is 9x. And these, despite what you may think, do not cancel out either. 8y plus 8y is 16y. So now it's just a matter of, okay, well, I have to eliminate one of them. Since they're both positive, let's make one of them negative. I am going to change the second one. How do I make this a negative? By multiplying it by -1. Now I'm going to backtrack a little bit because I never mentioned earlier why I chose to change this equation versus the first equation. Now let me explain myself. For me, whenever possible, I want to keep my variables positive. So I notice if I change this to a negative, I will still have a positive coefficient here. Now if I did vice versa, I'd end up with a -6 here instead. So whenever possible, try to keep your numbers positive because it's less tricky that way, so you don't have to divide by a negative. So in this case, you'll notice, because my x's are going to be left over, I decide to keep this one negative because it will still keep my numbers positive, and you will see in a second. We're going to distribute to every term. -1 times 4x is -4x. -1 times 8y is -8y. And -1 times 8 is just -8. I'm going to keep the first equation exactly the way it is, so 5x plus 8y equals 4. Now something that you're going to notice is I've successfully eliminated the y's, because positive 8y minus 8y is 0. So now 5x minus 4x is 1x equals 4 minus 8 is -4. Now 1x is the same thing as just an x, so x equals -4. I got part of my answer. Let's write it out. X comma y. X is a -4, so writing that in first. So now it's a matter of figuring out what y is. I really don't care which one you choose here because they're very similar. I'm going to choose the first one just because we haven't chosen the first one at all. So let's try that. We're going to do 5x plus 8y equals 4 with the reminder that we do know that x is -4. So plugging that in for my x. I am going to be left with 5 times the value for x plus 8y equals 4. So what goes in for x? Well, according to my work, x is a -4, so let's plug that in. We're going to simplify what we have. 5 times -4 is -20 plus 8y equals 4. Now I'm going to get rid of this -20 by adding 20 to both sides, leaving me with 8y equals 24. Almost done. We're going to get rid of this 8 by dividing both sides by 8, leaving us with y equals 3. So here is my answer. Now, of course, it's in your best interest to check this out and to see if it really works for both equations. If it does, you can confidently say this is your answer. If not, please go back and check your work. Now, for number 8, you're going to be given 4 minutes to try this by yourself. Your time begins now. Okay, so let's check out number 8. Let's see how well we did. You're going to notice everything lines up nicely, however, nothing cancels out. So I do want to change one of them. My goal is to eliminate x's because they're already the same, just they're the same sign, so one needs to change to negative. I have a choice between changing the first one or the second one. I am going to change the first one because by doing this, I can keep my y's positive, and you'll see in a second how that works. -1 times 3x is -3x. -1 times 5y is a -5y equals, notice I distribute to the very last term, so -1 times -5 is just 5. This is going to stay the same as 3x plus 8y equals -26. At this stage, you can see that I can confidently say the x's are eliminated, which just leaves me with 3y equals a -21. Let's divide both sides by 3. Y equals -7. So to begin our solution, we can go ahead and do x comma y. Our y is -7. Now just to figure out what x is, I can choose any of these two equations. Definitely would say the first one's a lot easier, so let's go ahead and use that one. 3x plus 5y equals -5. Let's not forget, we do know that y, not x, sorry, y equals negative 7. So we're going to take that and plug it in for y. Now I have 3x plus 5 times the quantity for y equals negative 5. What goes in for y? According to my work, it's a negative 7. So here we have 3x minus 35 equals negative 5. We're going to get rid of this constant, so instead of subtracting 35, we're going to do the opposite and add 35 to both sides, leaving me with 3x equals negative 5 plus 35 is a positive 30. So divide both sides by 3, and I'm left with x equals 10. Hopefully this is the answer that you got, and maybe you checked your work and you could have confidently told me that the answer was 10 comma negative 7. Now, of course, I didn't check the work because I want to make sure we were able to finish this lesson in time, but you should be checking your work to make sure everything works out for both equations. Now, this bottom portion we are going to save for tomorrow, so hold on to this and we will make sure to look at it tomorrow.